Hello students, in this video we are going to look into testing of hypothesis. These are the various steps involved in testing of hypothesis. First we need to formulate what a H0 is and H1 is. Select the appropriate test based on the problem and then choose the level of significance. After calculating the test statistic, we can determine probability associated with the test statistic and compare with the level of significance. At the same time, determine the critical value of test statistic and determine if a test statistic falls into non-rejection region. Once this is done, accept H0 or reject H0. That is based on comparison of table value with the calculated value. This will help when drawing conclusion, especially in marketing research. So we have a population group. In that population group, we try to select a small portion which we call it as a sample, and statistic X bar can be calculated from a small sample, and then there's a mu represents parameter of the population. So hypothesis testing. Statistical hypothesis, which means that it's a population parameters like a mean and a variance. The corresponding hypothesis stated with these two is called as a statistical hypothesis. For example, to determine the wages of men and women, whether they are equal or not, or it can be a product in the market is of a standard quality. Another example, like a particular medicine is effective to cure a disease or not. So in this way we can fix a statistical hypothesis. Parametric hypothesis can be framed in this manner. So the value of unknown parameters of a probability distribution whose form is known as parametric hypothesis. For example, if this X random value X follows normal population with a mean mu and variance sigma square, then it can be like a statement population mean equal to this mu1 or mu greater than mu1 or mu less than mu1. All these refers to parametric hypothesis. Null hypothesis. Null hypothesis denoted by H0, which states that the statement value of a population parameter such as mean or standard deviation is equal to some claimed value. We test the null hypothesis directly. So accepting H0 or rejecting H0, it will be any one of these two. Alternative hypothesis. It is a statement parameter that has a value that somehow differs from the null hypothesis. The symbolic form of the alternative hypothesis must use one of these symbols like not equal, less than symbol or greater than symbol. So types of alternative hypothesis can be what to put in one of these two forms. One is one-sided alternative hypothesis and the other one is two-sided alternative hypothesis. So if mu is equal to mu naught, then your alternative hypothesis one-sided, it can be like mu less than mu naught or mu greater than mu naught. For two-sided alternative hypothesis, it will be like mu not equal to mu naught. So significance level. The symbol alpha denotes the significance level. It is the probability that the test statistic will fall within the critical region when the null hypothesis is actually true. So common choices of this significance level can be like 5%, 1%, or sometimes it can be 0.1%. A critical value is any value that separates the critical region into two parts, right? So from the values of a test statistic that do not lead to the rejection of null hypothesis. The critical values depends on the nature of null hypothesis, the sampling distribution that applies, and the significance level alpha. So in two-tail test, we have the graph, right? This rejection of H0 region, which is highlighted with the pink color. Fail to reject a H0, which means we are accepting H0. So acceptance region lies between those two regions. A right tail test, usually when alternative hypothesis H1 represents with the symbol greater than. We always go for a right tail test, and the region of rejection, right, which is highlighted in pink color. So accepting H0 will be lifted to this. So left tail test, this alternative hypothesis will always have this symbol less than. So in that case, your region of rejection is highlighted in pink, and the acceptance region lies in the right side. So this is the way of a graph that we use for a two-tail test, the probability level. And this is for right tail test, and have the graph for left. So making a decision, always test done on null hypothesis. So initial conclusion will always be one of the following, like rejecting the null hypothesis or accept the null. The decision criterion follows this. Reject H0 when the test statistic falls within the critical region. Accept H0 if the test statistic does not fall within the critical. So there are two types of error that can occur during our testing of hypothesis. It's a type 1 error, which we call it as a mistake of rejecting the null hypothesis when it is true. Type 2 error, it is a mistake of failing to reject this null hypothesis when it is false. So in the form of a table, it is presented. So the decision can be correct when H0 is true, it should be accepted. Or the other one is when H0 is false, it should be rejected. In the other two cases, it falls under error.